Assalamu alaikum students. I am your chemistry teacher, and today we will study the chapter number 5, atomic structure. And first topic is subatomic particles of atom. And subatomic particles of atom, and definition of atom is matter is composed of very small particles called atom. According to Dalton's atomic theory, atom cannot be divided further. These are so small particles can't be divided further. However, modern research shows that atom is divisible, and several subatomic particles like electron, proton, and neutron have been discovered. Discovery of electron. First of all, we will study discovery of electron, and one by one we will study the discovery and properties of all the subatomic particles. And gas discharge tube experiment has been performed by William Crookes. And what is gas discharge tube? As you can see picture of a gas discharge tube, and there are two one is cathode and other is anode. Cathode is connected to the negative terminal of battery, anode is connected to the positive terminal of battery, and it is a glass tube having two metallic electrodes. It may contain gas, air, or vapors of any substance at any pressure. The tube can be connected to a vacuum pump to maintain at any low pressure. Electrodes are connected to a high voltage battery. The exact voltage required depends upon the length of the tube and the pressure inside it. Now we will discuss the discovery of electrons by William Crookes experiment. In late 19th century, William Crookes studied the passage of electric current through gases. For this purpose, he used a gas discharge tube. And the results of William Crookes experiment were: number one, at normal pressure, gases do not conduct electricity when even if the voltage is as high as 5000 volts. However, when the pressure inside the gas discharge tube is reduced and the high voltage of 5000 to 10,000 volts is applied, gases begin to conduct electricity and uniform glow appears inside the tube. When pressure is further reduced to 0.01 torr, the uniform glow disappears and the fluorescence appears on the glass walls opposite to the cathode. See here, these rays when strike the anode, then the uniform glow disappears and fluorescence appears on the glass walls. When these strike on the walls of the glass, these produce fluorescence. These rays are called cathode rays, and this fluorescence confirms the presence of the production of the cathode rays. The color of the fluorescence depends upon the composition of the gas of the glass. Different gases and vapors of different substances were used in discharge tube. Also, different metals were also used as electrodes, but always same rays were produced. Properties of cathode rays. These are the properties of cathode rays. First of all, these are negatively charged. Second property, they produce greenish fluorescence. They can cast shadow when opaque object is placed in their path. Rays possess momentum, and they can produce X-rays when they strike anode. They can produce heat when they fall on material, and they can ionize gases. They can cause chemical change. They can pass through a thin metal file like aluminum or gold. Charge per mass value of cathode rays showed that they are simply electrons. Okay, students, this was the topic of about electrons, discovery and properties. Now we will study the discovery of proton and properties of proton. In 1886, German physicist Goldstein took a discharge tube experiment. Properties of discharge tube experiment. Goldstein used a perforated cathode in discharge tube. When a large voltage is applied, a glow appears on the glass wall opposite to the anode. It is because some rays travel opposite to the cathode rays, and after passing through perforated cathode, they produce glow on the wall. Since the rays pass through the holes canals in the cathode, therefore these are called canal rays, and canal rays are direction of canal rays opposite to the direction of cathode rays, and these rays are called positive rays since they carry positive charge. How canal rays are produced? These rays are produced when high speed cathode rays strike the gas molecules present inside the gas discharge tube. Cathode rays remove electrons from the gas molecules and convert them into positive ions. These ions then move towards cathode as positive rays, and this is the mathematical representation of production of positive rays. These are the electrons show the cathode rays, and when strike the gas molecules, then it will push, or it will push out the electrons from the metal atom and expel out electrons from the metal molecule. Then it is converted into the positive ion. This is the show the loss of electron from a molecule, and this is called the production of positive rays, or canal rays are produced by the ionization process. Now we will study the properties of positive rays. Positive rays are positively charged. They travel in straight line. They produce flashes on the zinc sulfide plate. Charge per mass value of a positive rays is smaller than that of electrons and depends upon the nature of gas. Now we will move towards the next topic, discovery of neutron. In 1920, Rutherford predicted the presence of neutral particle neutron in the nucleus of an atom. It is because the atomic mass of atom could not be explained on the basis of protons and electrons only. Therefore, scientists thought that there must be another particle, and which must be neutral, and which is present in the nucleus of an atom. Chadwick discovered neutron, and by performing this experiment, Chadwick discovered neutron in 1932. He was awarded Nobel Prize in Physics in 1935. Chadwick bombarded the nucleus of beryllium with alpha particles and found that it gave highly penetrating radiation. Charge detector showed that these radiations as neutral, and these radiations were called neutron. And nuclear reactions, the neutron was produced as formation of formation of alpha particle from polonium, and formation of neutron. My dear students, as you can see, the equation of helium plus beryllium. Helium, alpha particles bombarded on beryllium, then it is converted into carbon atom and plus neutron. Here production of neutron in this is explained by this equation. And properties of neutron. Neutron cannot ionize gases. Neutron cannot ionize gases because it is a neutral particle. Number 2, free neutron decays. Free neutron decays to give a proton with the emission of neutrino and electron. Neutrino decay to give a proton with the emission of neutrino and electron. High penetrating power. Neutrons have high penetrating power. They can knock out high speed protons from paraffin, water, paper, and cellulose. Fast and slow neutrons. Neutrons traveling with 1.2 mega electron volt energy are called fast neutrons. Neutrons traveling with energy less than 1 electron volt are called slow neutrons. Slow neutrons are more effective than fast neutrons during nuclear fission process. Carry out nuclear reactions. They can carry out nuclear reactions when used as projectiles. For example, a neutron can eject an alpha particle from the nucleus of neutron and boron is produced. Slow moving neutrons produce gamma radiations on striking copper metal. In this process, radioactive copper is converted into zinc. Neutron is captured by the nucleus of copper and copper is produced. This radioactive copper 6629 emits an electron beta particle and its atomic number is increased by 1 unit. And the biological activity, these are used in the treatment of cancer due to their biological activity. Okay students, these are all the discoveries of electron, proton and neutron. Okay, thank you.